And I just want to caveat everything. This talk will be focused on R, but know that the strategies we're going to be talking about are abstract and could apply to any programming language, Python, et cetera. So what I'd like for you all to do is picture the scene. You've just launched your first machine learning model into production as a Plumber API, and your team loves it. Word gets out over a few weeks, and suddenly other teams want to start consuming your API as well. Maybe they use it as part of a feature in their Shiny application. Maybe they use the predictions as a feature in another downstream predictive model. The point is that your new service, this wonderful service called Appy, has now created value across various segments of your organization, and you've done the equivalent of a data science grand slam, and all is good. That is until it isn't. You show up to work one day, and the Slack messages start pouring in. It's like, hey man, I was trying to prototype a new feature in Shiny, and I'm not getting any responses back from your API. What's with that? Or another team may message you and say, like, hey, we're getting like cascading failures in like our ETL pipeline because we can't get your predictions for our machine learning model or something like that. So we're starting to struggle at this point. And you and your manager, you go through the logs and you see that your app is still up, it's still running. The issue is that it's struggling to handle all of this new traffic that it's receiving. So this brings us to an important question, which is how can we make our Plumber APIs more performant? Some of you may be in this talk and you have never made a REST API before. Not even sure what REST is. And that's awesome. We're happy to have you here. A quick recap of what REST is just a URL, but instead of returning like a web page, it returns some junk that looks like this, which is called JSON. And I want you to just take my word for it that this powers a lot of the modern web today. API performance is a huge topic that spans all sorts of ideas, and we won't be able to cover all of them in today's talk. So instead, we're going to focus on two ideas, two strategies. We're going to talk about minimizing serialization costs and maximizing responsiveness with async programming. And we're going to cover these in particular because they will improve your REST API performance. They're they require relatively minimal code changes, and there's great R packages for implementing them. So let's move to the first strategy, minimizing serialization costs. So when I say that, what does that mean? So the idea here is that serialization costs are the time it takes for you to take an R object in memory and turn it into some format that you can send over the wire, like JSON, right? You can optimize the business logic of your API endpoints, but at the end of the day, there's going to be this serialization cost that you pay to turn your R object, that's going to be the API response, into JSON. So there's an opportunity here to focus on, to start to zero in on like how your objects are being serialized to see if there's an opportunity to improve performance. So to think about like why this matters, I want you all to consider a scenario. I have a party, and I'm going to invite 100 people to this party. 200 doesn't matter. And I have two options. I can either send the invites through a handwritten postcard, or I can send them through email. To send all of these invites through postcard, I have to go get the postcards. I have to sit there and handwrite 100 postcards. Then I have to put them in the mailbox and then wait for them to get to their intended recipient. Versus with email, I can write my message essentially once and then send it to everybody on a distribution list, and because of the internet, it's essentially instantaneous. We want our serialization costs to be closer to email than to postcards. Because if we do that, we're going to be able to return our responses much faster. If we can return results faster, we're going to be able to handle more requests, things of that sort. So, sounds like a decent deal, good idea. How can we do that? So I have here a simple example of a Plumber API that uses what's called a serializer function to swap out the defaults and then get a performance boost. So how we go about doing this, the first step is find a package that serializes JSON faster. Out of the box, Plumber uses something called JSON-Lite, which is a robust, battle-tested package. It's great. But in this example here, I'm using something called YYJSONR, which uses a very fast C library under the hood to read and write JSON in record times. So once you've found your package of choice, then what you're going to do is you're going to write this little function, YYJSONR serializer. And what that's going to be used is, it's going to be used as a special function that you give to Plumber so it knows how to turn your R objects into whatever you're serializing it to. So with that serializer function, from there, it's very simple. You can go ahead and just use this serializer tag to say that you want to use your new serializer, and then your endpoint gets an immediate performance boost. There's no need to change the underlying business logic of your API endpoint. You just get the lift for essentially free. Now, on this tiny app, you're thinking like, this isn't a huge deal. But if you can imagine an API with 100 endpoints, then it starts to become like great from a maintenance standpoint as well, because now I can just change the serializer on my 100 endpoints and I get improvement across all of them. So we go back to our little web service appy, and we go ahead and we change out his serializer, and he gets a nice speed boost. He gets a 6 set of roller skates. So now, whereas he was trudging along before, now he's gliding through a little quicker. But we're not done yet. We can improve appy even more by using the second strategy that we have here, which is maximizing responsiveness with async programming. Now, to understand this strategy, we need to take a quick sidebar to understand how R and Plumber works out of the box. So when you have our API here on the left and our incoming requests on the right, how does Plumber process these? Plumber is an R package, and R is single-threaded, meaning that it can process one instruction at a time. So when those 3 API requests come in, your Plumber API is going to munch through each one of them sequentially. Now, for a lot of REST services, this synchronous execution model is perfectly fine, especially if your API has low to moderate traffic and the endpoints are relatively snappy. There's plenty of synchronous web services out there today. But when your traffic becomes higher, and your endpoints can vary in terms of their execution time, then this model of execution can start to get hairy pretty quickly. And to understand why, I want you to imagine that with these 3 requests, 1 is slower than 2 and 3. Say 1 takes 10 seconds, and 2 and 3 take 2 seconds apiece. The first request is going to take 10 seconds, but now request 2 doesn't just take 2 seconds, it takes 12, because it has to wait for request 1 to complete. And what's worse, request 3 will have to wait a grand total of 14 seconds, because it has to wait for the other 2 requests to finish. And you can imagine beyond 3 requests, if you're getting hit with 1,000 requests, then you're going to start to dogpile your R process, and it's not going to be a good time. So we need another execution model. And that's where async programming comes in. I like to think of async programming as just waiting or executing computations without waiting for them to complete, but intelligently. It's computational multitasking. To make it a little more concrete, I want you to imagine 2 ways of going about your day. One is that you brew a pot of coffee, you pour yourself a cup, drink it, then you get your bread, put it in the toaster, and then when it's done, you enjoy your toast. Versus the way that a lot of us do it naturally is you're gonna wake up, you're gonna start a pot of coffee, you're gonna throw your bread in the toaster, and then you're gonna wait for each of those things to complete, and maybe you'll sip on your coffee while the toast is finishing, but you're ultimately gonna be able to do those two tasks simultaneously without waiting for them to finish. And so what we want is an execution model that's closer to way two, and that's where async programming gets us, or what async programming gets us. So how does this work for something like Appy? So what's going to happen is, instead of having just one R process that's running our API, what we're going to do instead is we're going to spin up a certain number of child processes. And what we do then is our main R process is going to function essentially as like a relay, where as the requests come in, our API will direct them to one of these workers where the request will actually get processed. And so in doing this, we end up with this nice effect where request 1 takes 10 seconds, but now requests 2 and 3 now both take 2 seconds to complete because they're sent to dedicated workers and there's no longer a line, essentially. So that sounds like a good deal. That sounds good. So how do we go about implementing this in code? So to do that, you might have heard of something called Mirai by now. It's a great package for doing asynchronous programming, and it's the one we're going to use in this example. But you may be wondering, well, why not use the future package? The future package has been around for a while. It's another durable, battle-tested package that works in a variety of contexts, and it was used in the first, it has been used for asynchronous plumber work and whatnot up until today. I'm choosing to use Mirai in this example for reasons that are kind of like beyond the scope of this talk, but I'm happy to talk to folks about it later. So how can we go about doing this? So we have this basic example. It's another hello world example. And the way that we're going to go about doing this is we're going to use a function called Mirai, from Mirai called daemons, which is going to spin up 4 workers in this example, 4 R processes that are going to be lurking in the background there, waiting to do stuff. And then what we're going to do next is our business logic, okay, and our API endpoint is then going to basically get bundled up and passed into another Mirai function called Mirai. And what that Mirai function is going to do is it's going to take the R expression, or like the business logic that you've passed it, and it is going to run that code in the child R process. And then the important thing is that when it's running, or after it runs, it's going to immediately return something. It's going to return something called a promise. And the way to think about a promise is that it is a placeholder for the eventual result of a computation. Now, this notion of a promise, I'll kind of hand wave here, but the idea of a promise is what allows our API process to remain responsive to other incoming requests. Because when the promise returns, or like when we get our promise back, the main R thread is free to do other things, like intercept another inbound request. And the nice thing about Mirai is that once this promise is ready to go, when there's a result able to be fetched, it's going to inform the main R process directly, and then R is just going to send that result back to the client that requested it. So we go back to Appy, and we instrument some of his code with some async programming inside of it, and he gets another speed boost. He gets this sick jetpack. So now he's not just rolling along the street, he's rolling with like a Mach 8 engine or something like that, something real fast. And the end of Appy's story is that with these 2 strategies, it was sufficient for the web service to scale to meet the demands that our other teams were bringing to it. and all is right with the world again. Now, with that, what have we learned from Appy's story? So to just kind of recap. We have these two strategies that we talked about, which is minimizing serialization costs, really try to drive down the time it takes to turn our R objects into something that can be sent over the wire. And two, to keep our main application responsive by using asynchronous endpoints, or async programming in general. And then there's kind of like this third point that I think underlies like the two of these things, which is, R is much more powerful than you think it is. We have a lot of sophisticated tooling today that allow us to make very powerful Shiny apps, or in this case, Plumber APIs. And so a lot of the times, like folks on Hacker News may tell you that like R is great for prototyping, but not production. They'll tell you to take your API and like write it in like Rust or something like that. Myself and other people at this conference are here to tell you that you don't have to do that. A lot of API design or solid performance is about solid design, not programming languages. So I encourage you all to take some of these strategies that I've shown you today and use them in your own projects and see how they can take your own web services to new heights. So that's me. If any of you would like to talk about any of this further or just kind of hang here at the conference, I'm happy to talk to y'all. And then there's the QR code here to take you to some of the other ways that you can get a hold of me. But that's what I got. I'll take any questions you have.
Thank you so much. So we do have time for one question here. So what was the learning curve to Mirai for someone who hasn't used async programming before? And is future simpler for a newbie to learn the concept of async?
I do think that there is a learning curve with async. You do have to kind of wrestle with it for a little bit. I think that you can go either way between Mirai and Future. Both of them have just great APIs for like working with them. They're very user-friendly, so you can't go wrong with either one.
Okay. And is there a lot of overhead cost in using Mirai, startup, et cetera?
Yeah, so that's a great question, because the overhead, right, can come from the idea where now that we have these other processes, you have to send the data, right, your request over to these processes, and there's some overhead with funneling data between processes on the server. In my experience, like running some local testing before the conference here, I actually noticed that with the more recent versions of Mirai, like the overhead cost is like next to nothing, which is really cool. So I wouldn't worry too much about it.
Amazing. We have one more question here. So does Mirai run on a single thread? If so, does this affect the user experience and UI responsiveness?
So the important thing is that, so with R, everything is always single-threaded. The idea is that instead of doing multi-threading, we're doing what's called multi-process, which is where, so like if you spin up this API with several workers and you open, like Activity Monitor or Windows Task Scheduler or like whatever the monitor is, you'll see that along with like your API process, there will be like other R sessions that are running in the background. So it really shouldn't impact the user experience in the way that I think like multi-threaded code could, but.
Great. And I think we have one more question here. Why are faster serializers not the default for Plumber?
I feel like I may as well just kick that over to Thomas at this point. Yeah, he's a better guy to ask than me. The only thing that I'll say is that, choosing default dependencies for packages is a really complex thing, right? Because certain packages may be really fast, but they may only have like one maintainer that doesn't really work with the project anymore. So you got to choose your dependencies wisely there.
Great. Thank you so much.
Yeah, thank you.